Welcome to Pure Mathematics 1, Chapter 7, Trigonometry. Topic: Other trigonometrical function. So the first trigonometrical function I want to mention is the transformation. So there are two types of transformation. One is vertical transformation, and the other one is horizontal transformation. Horizontal transformation. So for the first type, the vertical transformation is transformation along the y-axis. So for horizontal transformation, it is transformed along the x-axis. Now I have the function fx equal to sine x, where x between 0 and 360 degree. Now I'll draw it here. Here's my 1, and here's my minus 1. So first I will draw the graph of this one first. Be from here down here, and here 360. Because our limit is from 0 to 360 degree, so I just draw this section of the sine graph. Okay, now I want to find the graph of the equation fx equal to sine x plus 1. So how can I do that? And here you can think that the equation is equal to y. So we have y, and here you have y plus 1, mean that all the value y for x value x will be increase 1. So we move the equation along the y-axis. Let me take another color to illustrate the graph of this one. So the graph of sine x plus 1 will be this one. Here you can see that this one is moved up 1. So at first this one is 1, but now it is moved upward 1, so the maximum point of this one would be 2. And here at first it is minus 1 plus 1 would be 0 in here. And now you can see that the distance from here to here is actually 1, because it is moved upward 1 unit. So all of the distance here, this is from here to here, or distance from here to here, all of them are equal to 1, because the whole graph of sine x is moved vertically by 1 unit upward along the y-axis. And now I want to find the graph of this one, fx equal to sine x minus 45 degree. How can I do that? And now I'll take another color. In order to sketch the graph of sine of x minus 45 degree, I will move the sine graph to the right 45 degree. So here's my new graph. This one here. Okay. And here's my 45 degree. And here must be 405 degree. And this one must be 225 degree. So it's a general rule for you guys. If you see any function in the form of y equal to fx plus s as a variable, it can be positive or negative. If it is positive, you will go up the y-axis, and if it is negative, you will go down the y-axis. This one is the translation of y equal to fx by 0s. So this one represents that it moved no unit in the x direction, but it moved x unit in the y direction. which is the y-axis, and no unit along the x-axis. Okay. And now you have a second rule, is that if you see y equal to fx minus t, it is a translation of y equal to fx by t0. It means that it moves in the x direction, t unit, but it moves in the y direction, 0 unit. So it just moves along the x-axis. So I know that my fx will be sin x, right, from the equation. And now I want to find the graph of y equal to sin x plus 90 degree. So if it is 90 degree, it is a plus in here. So substituting into this form, so I will have t equal to minus 90, because x minus 90 degree will be x plus 90 degree. So it will move in this direction because it's a negative number. If it is a positive number, it will move in the direction which is 45 in this case, x minus 45. And now I will have the new graph for this one. It will be, and we know that the graph of sin x starts at 0, so the graph of sin x plus 90 degree will start at minus 90 degree, and it would be like this, here and here. Okay. And now I will instruct you to draw a combination of vertical transformation and horizontal transformation. So I have a equation here, cos of x plus 45 degree plus 1. So how can I draw it? First of all, I have to draw the function cosine first. Here's my scale line. Here. Here's a 1, and here's minus 1. 2 here. Okay. So first of all, I will draw the function cosine. Here's my function cos x. Cos x. This point is 90. Here's 180. And here 360. Okay. And then I can choose either vertical transformation or horizontal transformation to draw it first. But in this case, I would prefer to draw the horizontal transformation first. Now I will draw this one, because this one is x plus 45 degree, so it will be moved to the left. So here's my minus 45 degree here, because at first it will cut the graph at 90 degree, but now it's minus 45 degrees, so it must cut the graph at this point, the 45 degree, and it cut the graph at 270 degree. So now it must cut the graph at 270 minus 45 degree, which is 225 degree, will be in here. Okay. So now we draw this one up here, cross this one, and up here. The ending point would be 315 degree. And then I will do the vertical transformation with another color, because it's moved upward 1, so I will move upward this one once. Here it would be something like this. Okay, I move this one from the blue line to the red line. 1. All of them are 1. All of this in here, 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 and here. All of them equal to 1. So this one is the final line, would be cos of x plus 45 degree plus 1. So in the exam, just draw one line and the two other line. If you want it to help you to make your drawing easier, you can draw it, but then you need to erase them because it will make the examiner confused which one is the one that you are drawing. And now we will talk about reflection. Reflection. If you have the function y equal to fx, so the reflection of this function will be y equal to minus fx. If I have the function y equal to fx equal to sine x, so this one will be minus sine x, and I will draw it here. Here's my function. So first I will draw the function sine x, which is this one. Here I will denote this one as sine x. And the function fx equal to minus sine x will be this one. Will be the one down here. They are symmetrical through the x-axis. Minus sine x. Let's say now I want to draw the reflection of the function cosine. Here I have my function cosine will be this one. So the reflection of my function would be this one. And here is a minus cosine. And now we will talk about stretches. There are two types, vertical and horizontal. For the vertical stretches, we will have the equation y equal to a multiplied by fx. And for horizontal stretches, we will have the equation y equal to f of ax. And now I will talk about the vertical stretches first. So first of all, I have the function fx equal to sine x. So this one will be this one. So it will be this one. And then I want to stretch it in the vertical direction. Let's say I have the equation fx equal to 2 sine x. So this one, 1, and here's minus 1. And now I want to stretch it twice, so it would be here's 2, and here's minus 2. It will be something like this. Yeah, it looks like this. When you have the range of sine x greater than minus 1 or smaller than 1, so 2 sine x will be smaller than or equal to 2 and greater than or equal to minus 2. That's how you can form this one, the vertical stretches. And now we are going to talk about the horizontal stretches, which is in the form of y equal to f ax. Let's say I have function fx equal to sine x, and I want to stretch it into fx equal to sine of 2x. So here is my scale. Here's 1, and here's minus 1. So first of all, I would draw my sine x first. Here's 90, 180, 270, 360, and 0. You should imagine that when you have the equations sine x and you want to stretch it into sine of 2x, you will compress it in the horizontal direction. So you would have something like this. Its maximum also 1, but now it goes through this point here, one down here and here. So at first you have only one graph, one full graph, but now you have two graphs of this one. And why is that? You have when your sine of 90 degree be 1, right? Sine of 90 degree would be 1, and now your 1 is up here, so your sine of 2x be 1. So you have 2x must be equal to 90 degree. So your x now is only 45 degree. 45 degree. We keep this one. If you change your function into sine of 3x, so 3x will equal to 90 degree, which is so x equal to 30 degree. So x equals to 30 will be this one. And your graph now look even more compressed than the other two. I stop here. You can see that when this number increase, which is number A increase, the distance for one complete oscillation decrease. So this one is one complete oscillation. Here, for the function sine x, it takes 360 degrees for one complete oscillation from this point to this point. For sine 2x, it takes 180 degrees for one complete oscillation. You can see the blue line. Here it ends one complete oscillation here. For the sine 3x line, you can see that it takes 120 degrees for one complete oscillation. So the more A increase, the more your graph will be compressed.